So, welcome to custom tables in customer service and sales and marketing. Tony said we should have a slide like this with our Twitter handles. Things that go tweet, they go into my cat. Facebook, yes, I have a daughter. She's on Facebook. I am on Facebook. I'm one of her friends because I have to see what she looks like to her friends. Anyway, we are both easy to reach, you know. This talk is about giving you a map, guiding you through the terrain of what we in our more theoretical moments call schema variability. The database as a schema describes what's in it. The first thing that happens to a schema is when it meets a customer is it doesn't fit anymore. It's like a battle plan, never survives contact with the enemy. That's why they call him the enemy. With schemas, you almost always want to put something more into the database than what the standard product gives you. And this is something we have known for a long time, since the beginning of SuperOffice. And we've made several mechanisms for doing that. And with eJourner, our customer service, we acquired some more. We try to tell you when is it appropriate to use what kind of mechanism. We are going to go in fairly deep into the details of each one, so that you can understand for yourself what it's for, why you should use it, why you shouldn't use it. I welcome feedback all along, or at the end. Typically, if there is something that looks complicated, there will be probably a slide that tries to explain it. If that doesn't work, then please do ask the question. Now, as we combined customer service and sales and marketing into one database, we found out that this was actually surprisingly easy. Those two database schemas overlapped in only a very few places, and in those places they overlapped in a way that we could add a few fields here and there, and bang, we had just one database. But we ended up with the variability and extension mechanisms from both products. And the story right now is a little bit patchy, because some parts are visible in one product, some parts are visible in another, some will become visible in both, and so on. So we're here today to guide you through it. And, well, maybe you get to meet this guy. He looks safe, doesn't he? So, the map, the overview. There are basically 4 different mechanisms you can use to extend what goes into the database. We have user-defined fields in the sales and marketing client, popularly called Udef. Those are intended for customers and CRM consultants to set up. And they supply more info about existing entities. They hang off of things that are already there. So you have user-defined fields for company, for person, sale, document, appointment, project. 6 of them. Then we have partner-defined tables, defined through the wonderful dictionary SDK. Those are intended for developers, programmers, people who write code, and who understand what a database table is, what a relation is. And you use those to add new functionality, things that are completely new, or add-ons to something, or to store your data, which you then use to influence functionality which is already there. The customer service part gives us 2 concepts, extra tables and extra fields. Extra fields are, and both of them are something that you can define through a user interface. So customers and customer service consultants can do that for you. The extra fields go onto existing tables, some the same as the Udef fields, some on other tables, which are more central to the customer service product. And the extra tables can, like partner tables, be anything. They can be related to existing tables, they can be related to each other. Technically, the map looks like this. There's a pointer somewhere. We'll just take it from the top. So each column describes one characteristic. Dict is which dictionary is updated. Where is the information about the tables stored? Because any kind of schema change in the database is useless unless some part of the application knows about it. How does it know? Because the schema change is described somewhere in some table. You could always ask the database about what the physical layout looks like, but that gets complicated when you have many kinds of databases and they have various ways of describing their tables, and some are case sensitive and some are not. Some will put quotes inside quotes if you put in something in quotes, and so on. So we have our own dictionaries. GUI, is there a user interface for manipulating the data in whatever fields, tables are added? Are they replicated in any way? What about web services? How about scripting? Is there an admin user interface to actually make the schema changes? Does the NetServer code, with or without the code generator, care about these things? And what about Sentry? And as you can see, there is nothing that actually does everything everywhere. And this reflects where these different mechanisms come from. And as you can also see, it says 7.1 in a few places, which tells you about our plans, how we want to improve this, how we want to make this story better. Because ideally, we would like, I think, one system to make it possible to change what's in the database. And those changes should be accessible all over our entire product line, which includes things like the Pocket client and other clients. We don't have such a system yet. Google calls this project the Big Udef Troll. And if you know what a troll is, in Norwegian mythology, it lives in the woods, it's big, hairy, and it eats people. So it's one of these projects that looks intimidating, and we are going to do something gradual to it. So 7.1 markers tell you something about what's going to happen. I'm going to start diving into the details now, so if you have any questions regarding the overview, you can take those now. If not, then we're diving. Udef. User-defined fields in the sales and marketing client. They live in fixed database tables. Now, some of you have been with SuperOffice for such a long time that you remember that it was not always thus. In version 4.5, we actually had a physical layout in the database that reflected whatever was the current user-defined layout of the user-defined fields, which gave us some flexibility, like you had an unlimited number of fields, or at least until the database crashed, which it would around 255 in those days. But it had the disadvantage that it was very hard to replicate. So every time you changed the layout, you would have to call in all your travelers. Clearly not a practical way to do things. And so when we made SuperOffice 5, we changed strategies. And so we have 2 tables. But that's just because of database record size limits that existed at the time. One table with ints, short strings, and doubles, and another table with big strings. And whatever layout you make simply uses these fields in some way. So there is a private dictionary, a table called Udef-field, plus a few other tables that defines how these fields are used, what they look like. So it defines both the schema and the user interface, the labels, the coordinates, and so on. And Udef fields are visible in the sales and marketing user interface. And that's one of the main characteristics. That's what they are for. And they are visible in actually quite a number of ways. Obviously, you can see them on the More page. You can choose 3 of them, and that's MDO, so you can have different 3 fields for different user groups on the front page. They will appear in column selections, they will appear in Find, in Archives, all over the place. They are not visible in the customer service product at all. That's how it is. Stanley is going to fix that this evening, I think. Maybe, maybe not. But for the time being, that's the way it works. This is a sales and marketing phenomenon. They are replicated. And what's more, they are replicated with conflict resolution at the field level, which is not usual. Our replication logic generally looks at one whole record at a time and decides which one is newer if you replicate the record and the receiving database already has it. So it looks which one is newer, the latest wins. There are some exceptions to this logic, but that's the general case. And the record that wins means all the fields replace the original record. But with user-defined fields, we found out that was not very practical because one typical usage is that you have some other system, some ERP system, booking system, or whatever, and you are regularly, every night, playing data from that into Udef fields. But you're not using the Udef fields only for this. You have a dozen Udef fields that reflect something from another system, and you have another few fields that you use manually. And if every night this dump then would cause all the local changes to become lost, that was not very good. So you have this field level conflict resolution, which means that for each field the system finds out the age of the field and then the latest ones. This takes a bit more traffic in the total transaction log. It is possible to turn it on in principle for any table if you want to, if you need to. If you give me enough chocolate, I will tell you how. Udef layout changes are also replicated, and that's one of the advantages of having a fixed database structure. We don't need any special database privileges, we don't have to alter columns, drop and recreate tables or whatever, because it's just the usage that changes. And the usage is just a table that describes how the fields are used. So we replicate changes in the description, and the layout changes also on travel clients. But travel databases are not always updated. So you go out on travel, you stay out for 2 weeks, your administrator makes a Udef layout change, you come back, what happens? We store all the versions of the Udef layout. So when you come back, we see, oh, you have version 9, we are now having version 10 as the current. Then we will look at the correspondence between version 9 and 10, and we will make any necessary transfers and conversions of the incoming data so it matches the current layout. And that goes across as many generations as we need. So if you come in with version 9 and we are on 21, it will take a little bit of time, but it's going to go through all the updates until it's on the current version and then it writes that. So it's quite a robust system, and it has a number of advantages. You can see Udef fields in web services. They are exposed in various ways on the main entity carriers. Like the contact entity, there is a string dictionary with a name and a value for each user-defined field. And the name of the field lives in the Udef field table in a field called prog-ID. And I'm happy to say that as of 7.0 SR2, there is a user interface for that in SRM. Finally. I got just too embarrassed not to include it. So you can see what the prog-ID is, you can change it. If you make duplicates, then it's your fault, and things will die. NetServer is going to crash, the website is going to go down, and so on. So take care so you don't do that. We didn't have time to put in duplicate protection. Yes?
If you have a driver on a previous version, and this things you talked about last sentence, move the prog-ID because you made a mistake. Then try to check in drivers so that you have to rescue them.
The replication generational gap thing is not looking at the prog-ID actually. There is a field in the Udef field table that explicitly says which one was this in the previous generation. So the data is going to move according to your layout changes, and the prog-ID on each field is whatever it is. But if you then have external applications, your own modules that use the prog-ID to look up, which field you get depends on where the name is. So you don't mess up the replication by changing the prog-IDs. The prog-IDs are mainly there for you. The replication uses internal links. And also a change from earlier versions, when you create new fields in SRadmin, now the prog-ID will actually be assigned immediately. So if you create 100 fields, you don't then have to go do something to each of them. That was another component. And the prog-ID follows the field. The first 4 fields of each type in the database tables have indexes. If you in SRadmin select that this field should be indexed, you are placing it physically in one of those 4 fields. Once you have used them up, the indexed box becomes grey because there are no more indexed fields left. Now, changing the indexed checkbox implies that the field physically moves from one place in the table to another. When we do that and you press publish, it's going to take a longer time because we actually have to move the data for you, and it happens in 2 steps. It's dumped into a temp table and then it goes back in to the new layout. And the prog-ID will follow the field when that happens, so that it's still valid, you will still get at those values even though they have moved. So that's one of the points of the prog-ID. In NetServer, you can also get at the definitions of the user-defined fields. So there is a service where you can ask, what are the fields? What does the layout look like? You can't modify them from there, not yet. We've heard that there is a web-based admin application being developed. And given the way we do things, that means that everything that happens in that admin application will be implemented using services that you will be able to call. So in the future, if you don't like our Udef editor, you will, in theory at least, be able to write your own. Whether that's an interesting exercise or whether it's too complicated to contemplate, I leave that to you. And I don't know what those services will look like, but they are going to be there because that's the way we make stuff. The prog-ID is also the identifier that you get on user-defined fields in archives, because the archive providers that are concerned with the main entities also pick up the user-defined fields there. That's why you see them as columns. The label you define in SRadmin comes out as the nice column label, but the internal name is again the prog ID. So once you have set the prog ID, you can predict what the column is going to be called in an archive, and you can ask for it. Also in the REST interfaces, once they get up. Code scripting and Sentry. So given the way that the Udef fields are exposed in NetServer and embedded in various other functions, the code generator itself is not applicable. It's not applicable here. There is no special functionality for scripting Udef in particular, but you can get at the Udef values from wherever you are doing your scripting. And there is this nice little doggy guarding Udef data as a dependent of the entity it's connected to. So Udef fields on contact are guarded by the contact sentry. If the contact is invisible, then the Udef fields are invisible. So it follows for any particular error. The admin GUI, don't you have it? I mean, it's nice, user-friendly, stable, safe, all of these things. Almost. Yeah. I didn't make it, what can I say? And the guy who made it is no longer with us. Excuse me? No, he was involved in the ticket system for Udef-Web. Oh dear. I may be unfair to him, so. The good things we can say about it is that it does have all of these practical capabilities, and most of our other schema variability systems don't do this. Now, any question with regard to user-defined fields in sales and marketing before we go on to the next subject? No? Good. Partner-defined tables. Those were defined, that system was created for you, specifically. We don't need it. When we need more database table, people come to me, lay offerings at the altar, and at some point they will get a new database layout. It's a funny smell in my office. Partner-defined tables are created using a dictionary SDK, which is a COM API that sits on top of a lot of C++ code that manipulates the dictionary tables that are used by the sales and marketing product. There are 10 tables: conceptual field, conceptual table, physical field, physical table, and so on. The dictionary SDK manipulates those tables in a fairly safe and, I would say, reliable manner. Tables defined in this way are seen, visible to the C++ code, NetServer, DB setup, functions like rebuild, import, export, fabric, and so on. All of them see this because that dictionary is central to everything that sales and marketing does with regard to the database. I know there are partners, at least one, who have made a nice GUI on top. So I'm not making one. And it supports all the database types in the SuperOffice universe and all the field types that we have remembered to put into the COM API. We may update that a little bit because I know there are a few holes there. But there is no user interface. Not for the administrative part, defining the tables, and there is no user interface for the tables and the data in them once they exist. That's up to you. You define the tables, you define the user interface. Now there's a lot you can do. You can get them into archives, and remember that both find and selection are archive providers. So if you get your tables into there, they will appear in the find GUI, they will appear in dynamic selections. There's one guy sitting here who has done that. At least. You can expose them in services, provided you write those services yourself. You can show this in the sales and marketing web GUI, provided you write the GUI configuration, code the data handlers, and so on. You can create sentries for your tables, either as dependents of existing tables or brand new. Sentry system is plugin based. If you create a sentry, you tag it with the name of your table, we will see that, oh, there is a sentry guarding this table. And whenever there is a database access, that sentry is instantiated and called in the same manner as our own. It does require a bit of coding, and there is a significant investment on your part in learning how to do that. So this is a fairly, let's say, heavy tool. It's a very powerful tool, but you have to go to school and teach yourself how to do it. Ask Tony, ask someone else who's done it. I'm sure he's happy to help for 5,000 kroner per hour. Okay. Partner-defined tables have several other interesting properties. One of them, which is maybe not very well known, is that you can make them appear in the import system in SLM, and you can actually do that without coding. It's just declarations. And you can either tack on your table if they are related. If you make a table that has a relation to contact, so it has a contact ID which is defined as a relation. If you put in the right stuff when you define it, its fields will appear in the import user interface, so that people can import flat files into a combination of contact and your table, which is actually quite powerful. Or you can define your own completely new independent import category that then talks about only your table or tables if they are related. The import system is very good at traversing relations, transporting IDs. You can actually you have circular relations, and it should be able to resolve that. Partner-defined tables can be set for replication. What happens if you have partner-defined tables in the current database but not yet in the travel database? Nothing bad. The data goes, except that the data is lost. You know, there's nowhere to put it on the receiving database. If it doesn't have the tables, it gets the rows and says, oh, I don't have this table, skip to the next. But if the table is there, it can be replicated. You can't do area management filtering, so if you set up for replication, everything you do gets replicated to everyone. So don't put passwords in there.
What happens if the layout is changed on the server?
Oh dear me. Then you might actually be able to crash it. So it's a good idea to ensure that when you install a new version of your partner-defined tables, you actually need to update all the replicated databases, and you have to do that manually. You don't have to pull them in, but you have to run the same kind of upgrade or installation or whatever you did on all related databases so that they match. It doesn't have to be in the same order, because the match is by name, but they actually have to be there and have the same layout, the same fields. Again, if you know which bit to flip, you can choose to have field-level conflict resolution on your tables as well. There is one particular case where you say replicate to prototype but not up and down. Now, what would that be useful for? If you have data that's static, you want to keep it that way, or if you have something that has a huge change volume, but it doesn't really matter if people are slightly out of date, then you might want to choose that. But certainly if you want to replicate up and down, then you should also take the replicate to prototype, because otherwise the prototypes, the travel prototypes will not contain your data, and it's all going to be fine. Then it will only see the changes. Code generation. Tony has a service where you can get generated NetServer code, C# code, that gives you the same kind of programmatic access to these tables as you do to any other table, any table defined by us. So you get table info objects that are strongly typed, that have strongly typed properties representing your fields. You get row objects that you can use to fetch and send data. If you are a good developer and you are making entities that consist of a number of tables, you can use the nested persist mechanism in NetServer to connect these and have NetServer manage the relations for you. Now, if you can't generate, or you don't want to, or it doesn't fit whatever you are doing, you don't have to do that, because there is a get table info by name, which takes a string parameter in NetServer. And that will give you a strongly typed object if it can, and it will give you a generic object if it has to. And then you can use indexers on the all property, which contains all the fields, and you will get access anyway. As I said, the Sentry system in NetServer is completely plugin based. It's a fairly large subject, but you can create a Sentry. It's not very hard. You put an attribute on the class saying this is a Sentry for table and name, and that will make our system pick it up and see, okay, someone is trying to read from that table. I'm going to instantiate the Sentry, and if the Sentry wants to, it can modify the query that's going down into the database. For instance, by ensuring that some fields are always fetched if you need them to evaluate the rows coming back, or to do something to the where statement, or put on an extra join, or whatever. And then when the data comes back, your Sentry gets to inspect each row, and then set what are the rights to this row. Can I read it at all? Can I read this field? Can I change that field? And then that information circulates back up through the stack to whoever looks for it. And if you say that this row is not visible, then our system will discard it afterwards. So you can make quite powerful security for it. Web services. There the story kind of falls apart a little bit. We don't have a generic CRUD get at table X service. Now, that's not because we are lazy. That's because we think that such services are generally not a good idea. We may be wrong, but that's what we think. We think that web services should be at a functional level, not just single records from single tables. A web service should not be chatty. You should call it to get something done or to fetch some complete object, which may or may not cover multiple tables. But it's generally not considered good form to expose your raw database schema as service. So that's why you don't have it. There is, of course, a backdoor in the dynamic archive provider, or what the CSGAN calls dot syntax provider, because that's an archive provider which simply reflects on the database schema. And so you can ask it for any field from any table, and it can traverse relations happily from one table to another until you get where you are going. And obviously you can end up fetching half the database, which will take the time it takes, but you can do it. And since partner-defined tables are in the main dictionary, the dot syntax dynamic provider will see them, and so you can access them that way. There's no ready-made service to, and no backdoor either, to update data in partner-defined servers. That is something you will have to make yourself. Now, I have about 1 minute for questions before there is a change of crew. So anything else? Any questions on partner-defined tables, user-defined fields so far? Then it's over to my esteemed colleague, Mr. Sverige. Big hand for him. Okay. This might
microphone is working quite well. So now we are moving over to the CS side. And as Mark pointed out, well, there were two pieces of software coming together, and we have kind of an image for that inside SuperOffice, where you're talking about pulling up the zipper, connecting things. And we keep pulling it up further and further, so the biggest jump initially was merging the databases, which gave us now one database, but as Mark pointed out, with two schema variability systems. And so now I will cover what is currently in the, what should we say, the CS part, the customer service part of schema variability. And I think we're quite certain that in the future we will pull the zipper even further up and get it something even more unified. But currently, this is what we have. So, on the customer service side, there are two areas as well. As you can see a little picture there up in the right-hand corner. I'm sure all of you can read that text clearly without any problems. What we're talking about in customer service as well is extra fields and extra tables, which is totally parallel to Udef and partner tables. And so we have customer service extra fields that allow you to extend on existing entities, the ones we have right there. Request category, company and contact, FAQ category and entry, request and message and user. Probably request is the most commonly used one, right? You have the request in your system and you want another field to indicate whether or not this was replied to by phone or not, or if this is related to product A or product B or something like that. And so this is a system that allows you to extend our standard entities. And in contrast to the sales and marketing approach, we have never had in customer service, we've never had a travel system. There's never been more than one single database in one location. We never had the difficulty of getting in a travel system in schema. Which means that when we make changes, we can do it right there in the database. We don't have to consider anything else. And consequently, when we create extra fields, we are adding them directly on the table. When you're adding an extra field in the database, we are adding an extra field on request, for instance, we do alter table, ticket, add column, blah, blah, blah. And then also, of course, we have our own meta table, because as Mark pointed out, you can't really ask the database how you look like. That's going to be way too awkward. And also, you need more meta information than what you just get out of the database description. So we have a table called extra fields, surprise, where there's information about the extra fields that you have created in the system. And to make sure that you never, ever, ever create a field that might collide with a future expansion that we'll think of, let's say that you wanted to create request, a new column there that you would call SLA, and then down the road we're going to come up with an SLA system and you would have stolen our column, right? And that would cause problems. So we limited your namespace to a field with X underscore. So this is what it will be in the database. Inside the user interface, of course, you create your user-friendly names containing space and Norwegian characters and whatnot. But in the database, it will be X underscore something. It will show up in the user interface in relevant screens for entities. Again, a difference there. We don't have absolute positioning of fields as you have in sales and marketing. They will show up, for instance, on the request card or on the company card as another field down there. And then there's an editor where you can move fields around, not pixel positioning, but ordered positioning. So this is how you play around with extra fields. This is a list of the supported column types. As you can see, it's kind of our own meta level on top of regular database level. So you have the obvious basic ones: integer, float, text long, and then a bit further down there we have text short, and they will be, well, text long will be a club field, and text short will be a bar chart. Time, date and time, date, And actually these three, I believe, are in the database represented as the same data type, but by choosing here, more specifically, if you want date or datetime or time, the user interface will give you the appropriate control. Right? And then there are some other ones that you can see, contact relation, company relation. So these are also in the database only represented as an integer, as a foreign key. But in the user interface, we will know that, yeah, this is an integer in the database, but in fact it's a relational to company, so we will show the company name and we will show it as a link that you can click and navigate to that company. Typical scenario could be that, let's say, the default layout of the database is that on a request, it's related to the customer, but let's say you also want to indicate who is the selling partner. And so you will create another company field on the request that you will call partner, x_partner. And so when you're looking at a request, you will get this is the customer and this is the partner. Two relations from request to whatever you have in your list or register of companies and partners. And unfortunately, it's not available inside sales and marketing. That zipper is it's not quite there yet. And we don't have no travel, no satellite. So if you are in a travel satellite environment, you will get this in your central database and nowhere else. Feel free to pop questions.
Plans for that?
Oh, so many plans. Yes, we have plans. And seriously, we have been playing around with how can we get this troll going, how can we get this thing together. But it's not easy. Like I said, there is a reason for why in customer service we chose to place these fields directly on the table, because that works perfectly well when you don't have travel. When you have travel on satellites, it's more complicated. So we are thinking about this, and I'm guesstimating. I'm pretty sure that this will not show up in 7.2. I think inside R&D we are guesstimating a bit further down the road, because it's a huge project. I think what we will try to do, though, in the meantime, that hopefully we can get into maybe, well, probably not 7.1, but probably 7.2, some of this can start moving a little bit closer to make it somewhat easier. We have been playing around with some ideas. But the full-blown, super gold, shiny solution where it's on travel and satellite and everything, it's a lot of work actually to set that up.
But it is a question that the request tab you have in C for sales and marketing, we can see the request.
Yeah.
And you can click on the request and see a little bit about it. That doesn't work on the satellites. Would that be?
Yes, that's.
That's
that's a different issue, and that's a much more urgent issue.
Yeah.
That the request tab is really not working at all in the satellite environment.
Because it was not in the SR2.
No, yeah, it's not in the SR2. This one is complicated as well, because the request, the ticket table, it's in the database ticket table. It's one of the tables that's owned by the CS part of the system. And consequently, it's not replicated. There is no travel or transactional or anything for that table, which means we don't have conflict resolution or anything like that. So I'm guessing one way would be to have it included in that system, but and maybe that's something we could look into. Can't promise anything, unfortunately. And we know it's awkward. I believe that's one of the reasons for why in SR1 or SR2 it's the possibility of disabling that panel, that grid, I think, on satellites, for instance. And of course, you always have the option of having a web panel in there. I know it's not that great, but you could create a web panel showing the requests for that company. And of course, that will work on satellites and travel if you are connected to the internet. Okay, so that's for the extra fields, and then we have the extra tables, as you can see up there in our little fancy little matrix that we're now on the bottom one. And extra tables came to the customer service product after we saw that, hey, extra fields is kind of cool, but I want to register not only one value for this company, I want to register all the products they have purchased from us, and it's so difficult to cram all that into one single field. And so we saw the need for creating something very similar to partner tables. And so you can create your own custom table, and there's a namespace conflict resolution concept there as well, to make sure that you don't create a table that might in the future collide with the table that we'll come up with. It has to start with y underscore. Which gives you a bit funny names, but still, inside the user interface you can also give it a friendly label name. So this is only what happens in the database. And of course there's a, into the database there's a create table, y underscore equipment or invoice or whatever you want to create. And then it gets a few of our standard columns. And then after that you can create your own x underscore columns in it. So you can build your own table totally from scratch. And it's in a separate dictionary now. As I said, extra fields are in the table extra fields, and extra tables are in the table extra tables. And these are separate from the dictionary of sales and marketing. And it's also a different mechanism, because all the tables in sales and marketing, in fact now all the tables in Unified Database, are using the sequence table to get new unique IDs per row. With the exception of these guys, that has an ID column that has an auto-increment. So it uses the SQL database mechanism for creating a new unique identifier per row. Right? So when you insert into this row, the database will say, well, you just got a new number, you run row number 5, and that's how it works. They don't have any place in the sequence table. And thanks to Marek and some late night coding, EW setup, import, export, and rebuild handles them correctly in the 7.0 SR2. They are seen by NetServer, meaning that NetServer now not only looks at its own standard dictionary, but in fact it also peeks over at extra fields and extra tables, and you get them in to NetServer. And you can use generate table info object encode. Now, Mark added that comment. I don't even know what it means, but I'm sure you guys know what it means. And you can use the .syntax provider, the dynamic provider, to, as Mark said, you can query along pretty much anything in the dictionary, including then these tables. So you can use the .syntax provider for an archive inside sales and marketing, and you can query y underscore equipment something and get yourself a native grid listing stuff inside sales marketing clients. NetServer does not support insert or update on these tables. 7.1 probably will. We have thought about, really one of the main challenges is the difference in how we create unique IDs. Right? How the CS system just does an insert and get the ID from the database. As for the rest of the tables, we use the sequence table to get the next unique ID. And we thought of a solution to fix that in a small localized area. So we'll get that into 7.1. And then CodeGen will be available, and it can make C# classes for you for these tables. Then you will go into customer service and the admin, and you will create your tables, and then afterwards CodeGen will be able to create classes for you. Okay, and so maybe this is well-known stuff, but just pointing out what are the extra tables in customer service and how can you use them. And very frequently you want to use the extra tables in customer service to create, well, a new kind of entity that you want to relate your existing entities to. And if we try to look at this, a piece of software that just has tons of stupid entities is not very interesting, right? Because you don't get business logic on this, you get CRUD. You create an entity and you can create, you can update, you can delete and retrieve those, what should we say, flat entities. So I would say that a software that contains only stupid entities is not very interesting, but our software has actually tons of native entities, right? We have request, we have customer, we have company, where there's tons of business logic that we have written days and nights for how these intelligent entities behave. But very often when you are with a customer, that's not enough. The customer goes like, yeah, I have all of this in my company card and all of this is great, but I also need to store somewhere what this customer has purchased, or what licenses they have, so that I can keep track of that, or what kind of equipment I have installed there. So when the customer calls me, or when the sales guy wants to see, this is a customer, what did I sell them? You can get a list of these entities. Not with a lot of fancy business logic, but you can get a list and you can manipulate that data. And what you can do with these extra tables is that they can be related to standard tables in the system, and they can also be related to each other. So you can, if you go crazy, you can create your own, I don't know, ERP system or whatever using this. Of course, we don't recommend it, but you can create as many tables as you want and create pretty much any table structure you would like. And as I mentioned, it doesn't show up on travel, doesn't show up on satellite, but you can create web panels inside customer service that can be shown inside sales and marketing. So that means that, a typical scenario is that you're inside sales and marketing and you're looking at that company and you have the list of activities and you have a list of persons, and then you have a new tab that shows a web panel from customer service that lists, for instance, the products they have purchased. So here's one example of how you can extend it. This is the default structure of customer service. A request is connected to a contact that is related to the company. And you go, okay, that's not enough. I have a set of products that I'm selling. I have a food bar, and I have a dishwashing machine, and I have a blender, and these are 3 products I'm selling. And I need to keep track of which customer has purchased which product. So I create a product table, 3 rows in there, and then I create a new table that I call purchase that will allow me to register that this particular company has purchased this blender, maybe on this particular date with warranty expiration date or something like that. And then when this customer calls in and says, the blender that you sold me is not working anymore, well, then I also want to be able to connect the request to that particular purchase, so that next time the guy calls in, I can see that, yeah, on this blender we have had actually 5 requests earlier, even though they got reported from different guys in that company, or something like that. And so you can create this table structure, and then it will show up in the user interface. And of course, this is one of the bonuses, is that you get the user interface free out of the box. You create the table structure, and inside customer service, when you are looking at a company such as the well-known Vandalay Industries, it now shows up with another tab containing the products they have purchased. And you can click on that product, and you can see who purchased this product, and then you get the relational view the other way. I should have made that grid look better, but as you can see, it's both by SuperOffice Sweden and Vandalay Industries. And so you get this kind of meta information about these customers and what they have purchased. And in a customer service setting, that is very useful, because the customer is dialing in and you want to know instantly what have they purchased. And then, of course, these tabs can also be made inside sales and marketing. I have another one here showing that particular unit. So that is one remote control, serial number 345 something something. And we can actually see that, wow, the customers have complained about this 4 times. There are 4 requests in our support system related to that particular remote control that was sold again to 2 different companies. And then we put it inside sales and marketing so that your salespeople also have an easy view of what products did we sell to SuperOffice Sweden. A little bit more about the extra tables. How can you access them? Well, now I've shown you that you can build them and you have the user interface for them. Then you can access them using SOAP, Web Service API, for accessing them. I would say that this is it's a stupid API. It doesn't really give you any checks or boundaries or anything like that. It allows you to get the meta information, what extra fields are in the system, what extra tables are in the system. Okay, so I see that these are the ones. Well, I would like to query them, I would like to insert into them, or I would like to delete from them. So a very simplistic prod-SOAP interface for manipulating data inside those extra tables and extra fields. And obviously you can't have specific methods, right? Because the SOAP interface was created way before you created your extra tables. That's why you only get generic methods. And of course also when you are working with our strongly typed entities, such as a customer or company, well then setting extra fields on those is possible also through a value pair kind of construct on those entities using the SOAP methods. And then if you're not on the outside, but you're on the inside, in other words, you don't want to create something in, say, C# or PHP or something that's remote controlling our software, but instead you want to create a script inside our software, an embedded script. Wow, look at that awesome font. Didn't look like that when I created the presentation. Anyway, if you're programming in our embedded scripting language, ejScript, you also can do the same things. Of course, if you load a customer entity, you can go customer, load something, set value, my extra field, and then the value I want, and then save, and that works out of the box. And there is also a class in there that's called extra table that allows you then to get control of any extra table in the system and set any value, load, read any value, and then save. So you can write your own scripts that will manipulate the contents of these data. And it's kind of the same thing here, that clearly our extra table object here is generic, because we have no idea, of course, of what kind of extra tables you're coming up with. So you don't get strongly typed objects, you get generic objects that calls set value and get value on whatever fields you have created on that table. And the dot syntax provider, or the generic provider that Marek has been talking about as well, is available inside customer service and allows you to query all of that. Of course, I mean, it allows you to query that from when you are using it as an archive provider or when you're using it inside ejScript. Same thing. And we also have access in ejScript. You can also access Udefs. But then, unfortunately enough, you can't use, what should I say, customer service native customer class, but you have to use the NetServer services. But all of them are exposed through ejScript. So you can write a small ejScript that will set the user-defined field, for instance, for a person or a contact. So this is pretty much, I think, an overview of schema variability, how it works now in SuperOffice CRM. And as you see, there are, what should I say, it's still it's two different caps, but they are merging to some extent. And of course, we'll focus on that down the road. And I think it gives you a pretty decent flexibility for adding custom data to the CRM system, because obviously when you meet your customers and they go like, yeah, this is great, but I need to have something on the side. And then you can use these tools to develop and customize that. Any questions? No? All of this was easy, straightforward. Piece of cake, walk in the park.
There will be a short exam of the judge.
Yeah, exactly.
Multiple choice.
Multiple choice, 102 questions. Well, in that case, I think we will thank you for attending our presentation, and please evaluate. Thank you.